Hello everybody, this is another video from chemistry again from the chapter of first chapter of Form 5 chemistry, rate of reaction. And under the chapter of rate of reaction, actually a lot of students face problems in the collision theory. So for this particular video, I will share with you on what is the collision theory about and how to explain in terms of collision theory. Look at the collision theory. We must fulfill the 2 points which are very important in the collision theory. So what are they? For a reaction to occur between two particles, the reacting particles must collide with each other with the correct orientation, and they must also collide with a minimum energy called the activation energy. So for example, we have a particular reaction A plus B to form C plus D. So as usual, the A plus B will be the reactants and C plus D will be the products. So for this particular reaction to be successful to form the products of C and D, the reacting particles must collide with each other with the correct orientation. That means A and B must collide with each other with the correct orientation. First thing first, collision must happen. And the second thing, the collision must collide at the correct orientation. Then, they must collide with a minimum amount of energy. This is a keyword, minimum amount of energy, and the energy is called the activation energy. So during the collision, when they collide at the correct orientation, they must also collide with the minimum amount of energy called the activation energy in order to form the products C and D. So what is the activation energy about? This is the definition of activation energy, in which activation energy is the minimum energy required for the reacting molecules during the collision in order for a reaction to occur. Activation energy is the minimum energy required. That means during the collision, when they collide with each other, they will gain energy. And this energy, sometimes it is more and sometimes it is less. A minimum amount of energy must be required in order for the reacting particles to form the products. So this minimum energy is called the activation energy. Okay, so let me explain in detail on these 2 points again by taking an example. When we say we need a collision to be successful for a reactant A and B to form products C and D, they must possess correct orientation during the collision. The correct orientation means the correct sides of the reaction. For example, taking a very simple example, when hydrogen molecules react with bromine molecules to form 2 molecules of hydrogen bromide. So hydrogen molecules is a diatomic molecule like this, and the bromine molecule is bigger, is another diatomic molecule like this. So when they collide with each other, how to justify whether it is a correct orientation or it is a wrong orientation? Let's say, if the hydrogen molecule and the bromine molecules collide with each other and they collide this way or they collide this way, then this one will be the wrong orientation. If it is a wrong orientation, that means the sides are wrong. The sides during collision are wrong, and hence no reaction will happen. But if during the collision they collide this way, this is a hydrogen and this is a bromine molecule. So let's say they collide this way. So they collide at the correct orientation because the O bonds between hydrogen and bromine must be broken. During the collision, if they collide at the correct orientation, at the bonds, then the old bonds will be broken. And when the old bonds are broken, definitely new bonds will form between hydrogen and bromine to form hydrogen bromide molecule. So this is the product. And because of this, we call this one as the correct orientation. So because of the correct orientation, when they collide, according to collision theory, when the reacting particles are colliding with each other at the correct orientation, they have considered to achieve the first point. So not to mention the minimum amount of energy yet this reaction can happen. So now we will have the H and Br product formation. So now, how about the second point on the activation energy? For the second point of the collision theory, it says that they must collide with a minimum amount of energy called the activation energy. So for example, you can understand an energy level diagram in this way. Okay, this is a simple energy level diagram in which the y-axis is showing the energy of the whole reaction, while the x-axis will show the reaction pathway or the reaction coordinate from the reactants change to the products. So usually the reactants will occupy the left-hand side and the products will occupy the right-hand side. Taking the example just now, where we have hydrogen and bromine molecules to react to form two molecules of hydrogen bromide. So the hydrogen and bromine molecules are the reactants. And this one, while the other reactants, while the hydrogen bromide molecules will be the product. So now, look at this energy level diagram. One can see that the reactants are colliding with each other over here. And in order to go to the products, the reactants need to climb up a hill. Can you see the hill? This is the hill. So the reactants need to climb up the hill in order to form products. And this particular energy hill, look at the energy axis from the reactant energy level going up to the top of the hill. This is what we call the activation energy. The minimum energy required for reacting molecules during the collision in order for a reaction to occur. The minimum energy required. Look at the energy level from the energy level held by the reactants, okay, until the top of the hill. This is the minimum required. They can actually have more over here or over here or over here, but this is the minimum that they must possess in order to cross the hill and come down to form the products. So this is the meaning of activation energy. So that's why when you label the activation energy, you must label the energy level starting from the reactants until the top of the hill. Okay, in short, this is the meaning of activation energy, and we have covered the 2 points of the collision theory. So let's say, to strengthen this point of activation energy, let's say, for example, if a particular reaction having collisions over here and they couldn't get up to the top of the hill and they slide down, then no reaction will occur. But if a particular reaction and during the collision of the reactants, they manage to go up and go up and go up and cross the energy, the highest energy level of the hill, which is the activation energy, then they will come down to form the products. So for this particular reaction, it is a successful reaction. So now we go back to the point over here. When we discuss about the collision theory, we have to know that we must always remember that in order for reaction to happen, reactants must collide with each other and form products. So during the collision, they must collide with correct orientation, and they must collide with a minimum amount of energy called the activation energy. So during the collision, this is the most important point for the whole reaction to happen, because without collision, we cannot achieve this, and we also cannot achieve this. So in order to explain on collision theory, in related to different questions of factors affecting the rate of reaction, one have to know a few important keywords stated over here. Okay, so as what we mentioned just now, for a reaction to be successful, collision must happen. So collision must happen. So if usually when the collision happen, sometimes if they cannot possess these 2 points, they cannot fulfill these 2 points, the collision is unsuccessful. If the collision is unsuccessful, that means no reaction will happen. If during the collision, they manage to fulfill these 2 points of the collision theory, that means this particular collision will be successful. Okay, so let's say during the collision, when in a particular collision, they fulfill the correct orientation, they also fulfill the minimum energy requirement, which is the activation energy of a particular reaction. That means this particular collision is successful. When we say the collision is successful, that means it is effective enough to form product. So we term it as effective collision. So from the collision can be effective, can be non-effective. If a collision can fulfill the 2 points of the collision theory, it is called the effective collision. When we have effective collision, that means the reaction is successful, the product formation must happen. So these are the important relation from the collision to the effective collision. When we have the product formation, that means the whole reaction is successful. So now, usually when we explain on the collision theory, we will explain it this way according to different factors. So I will talk about different factors independently in other videos. So for this particular video, we will still cover these few keywords in this orientation, in this flow. So usually when we talk about a collision, when we say the collisions are successful, that means it is effective. So let's say taking an example of effect of temperature. We know that higher temperature will lead to higher rate of reaction. So that means higher temperature, the molecules will absorb more energy, or the kinetic energy of the reacting particles increase. So when the kinetic energy of the reacting particles increase, the collision will increase as well. So when the collision is increased, we talk about how many collisions per time, and that is by using the word frequency. So when we say the collision increase due to a factor, that means frequency of collision increase. When the frequency of collision increase, definitely the chances of effective collision will increase as well. And so come to here, frequency of effective collision increase. Okay, so from frequency of collision increase, we will come to here to say that the frequency of effective collision will also increase. So when the frequency of effective collision increase, that means the rate of reaction will increase. So these are the three common points to explain in terms of collision theory. Okay. So now let's wrap up the video today regarding the explanation on different factors according to collision theory in rate of reaction. So usually the explanation of collision theory will be associated with any factors in the question. The factors can be total surface area, or an increase in concentration, or an increase in temperature, or the presence of a catalyst. So usually when we talk about any factors will do, the keywords for the collision theory will always be the same. Increase in collision due to the factor will help to increase the frequency of collision, and increase the frequency of collision will then increase the frequency of effective collision, and after we increase the frequency of effective collision, the rate of reaction will be increased. So to summarize it over here, so point number one will always, because of different factors, lead to an increase in collision. After the increase in collision, so the increase in collision over time is called the increase in frequency of collision. And from the increase of frequency of collisions, there will be increase in the effectiveness of the collision to come to here. That's why we call it as increase in frequency of effective collision. And the last point will be to summarize it, which is the increase in rate of reaction. So with this video, I hope you understand how to relate the different keywords in the collision theory, and also to understand well on the 2 points of the collision theory, in which the reacting particles must collide with each other with the correct orientation, and they must also collide with a minimum amount of energy called the activation energy. The definition of activation energy is also important, and you have to understand and remember the keywords. Then we will explain in this routine. That is, different factors lead to increase in collision, from increase in collision to increase in the frequency of collision, and from increase in frequency of collision to increase in frequency of effective collision, and then to the rate of reaction. So not also to forget how to label the activation energy. That is, from the energy level of reactants up until the top of the hill of the whole energy level diagram. So this will be the activation energy. Thank you.